Hello class. In the last video we talked about angular displacement, angular velocity, instantaneous angular velocity, angular acceleration, and instantaneous angular acceleration. So now I want to use these ideas to derive the kinematic equations of rotation. So let's just go ahead and write down our average angular velocity, and it's going to be at this position, this angular position, minus this angular position, divided by t. So in this particular case, let's go ahead and call this equation number 1. All right. So we can define the average angular velocity like this as well. Our instantaneous velocity plus our final instantaneous angular velocity all over 2. Okay. And then we want to look at some constant acceleration. And so our constant acceleration is going to be defined based on our instantaneous angular velocities as well. Divided by t. So we want to go ahead and derive the necessary kinematic equations. And so let's just start with equations number 1 and 2. All we'll do is just set them equal to one another. And this is going to be our first kinematic equation. Okay, so I'll just refer to it as 4-1 to indicate that it's the first kinematic equation. We'll use equation number 3 here, and we'll come up with our second kinematic equation. And this is just omega f is equal to omega initial, and these are instantaneous angular velocities, plus our instantaneous angular acceleration times the time interval. All right, so we're going to call this equation 4-2. And what we're going to do is we're going to take omega f and put it into this equation, and we'll also bring t over to find the angular displacement. So remember, we had theta f minus theta initial equals to omega f minus omega initial over, no, that's not minus, it was plus, over 2 times t. And we have omega final equals to omega initial plus the angular acceleration, instantaneous angular acceleration times time. And again, we're going to substitute this equation in here. So we end up with omega initial plus alpha plus omega naught times 2 times t over 2, and this is just going to end up being omega naught times t. I'm just going to distribute this through. I'm going to group inside of the parentheses first, and then I'm going to distribute through, plus 1/2 alpha t squared. All right, I'm going to call this 4-3. There is another kinematic equation, but I'm not going to worry about that right now. I just want to give this much to you guys. Okay. In the next video, we're going to talk about the connection between tangential velocity, and I'm just going to put a t here, and angular velocity, as well as tangential acceleration, and angular acceleration. So there is a relationship that connects them, okay? And we're going to explore that in the next video.